This is part 2 of the video notes for Objective 1E inverse function. And in this part of the notes, we're just going to be solving equations of functions for their inverses algebraically. And really this part of the notes is just going to be a handful of examples where I remind you the solving techniques to get through each type of equation. So as you see in the packet, the first example, or example 7, is f of x equals 2x plus 1. And an inverse function is solved using 3 basic steps. Step 1 is to switch x and y, or your input and your output. Step 2 is to then solve for your new y. And the last step, which is to me one of the most important steps, is to rewrite your function using proper notation. And that's in this one, we want to switch our x and our y. Well, x is our input variable and y is our output variable, which in this example is being represented by f of x. So we're going to rewrite the function as x equals 2y plus 1. And so we have literally switched the position of the output and the input. From here, we've technically got an inverse function, but we do want to solve it for y. To solve this equation for y, we need to subtract 1 to both sides. X minus 1 equals 2y. And then we need to divide both sides by 2. Since neither of these numbers are divisible by 2, I prefer to leave it as a single fraction rather than simplifying it. From here, I have y equals x minus 1 over 2, and I want to rewrite the equation using inverse function notation. So the inverse of 2x plus 1 is x minus 1 over 2. Let's try the next example. Example 8 is f of x equals the square root of x plus 2. We want to switch the x and the y. So we'll say x equals the square root of y plus 2. And then we want to solve the equation using our standard solving techniques. The inverse of a square root is to square both sides. X squared equals y plus 2. One more step, and y is by itself. Rewrite using your notation. F inverse of x is equal to x squared minus 2. So what's the inverse of the square root of x plus 2? Well, it's x squared minus 2. When you go to do the practice problems from your book, the book actually asks you to find the inverse algebraically and graph the function and its inverse on the same grid. And that's an important part of this assignment. It's going to help reinforce some of your 1B skills with graphing functions. So I'm actually going to graph these and just demonstrate to you that graphical relationship that you saw in the last video. My graph won't be too perfect. I'm going to freehand it. So I'm going to go 6 in every direction. But we should see a reflective relationship across the line y equals x when we graph these two functions. So let's start with the square root. This square root function has been shifted to the left 2 units, and the square root function has a 1, 1 and a 4, 2 type of pattern. Right there. What does this function look like if it's flipped over the line y equals x? So here's that line. Oop, that's not a very straight line. Let me try that again. Like so. And so I need to see this red function reflect across that line, but in reality I can just draw my inverse equation, which was x squared minus 2. This quadratic has been shifted down 2, and a quadratic goes over 1 up 1, over 2 up 4. Now notice what I'm not doing. I'm not drawing the other half of the equation. And that's because in order for these functions to be inverses, we can only look at the portion of the quadratic that matches the radical. And that's always going to be the positive portion of the graph when x, in this example, when x is greater than 0, unless we're talking about the negative square root. So this inverse comes with a restricted domain. It's an inverse when x is greater than or equal to 0, or basically to the right of its vertex. Example 9 is another type of function that we haven't spent a lot of time practicing with, and that's the reciprocal function. We'll have an entire unit dedicated to reciprocal functions, but we should still have enough algebraic skills to find an inverse of equations that look like example 9. Example 9 is f of x equals 1 over x minus 3. Step 1, switch x and y. Now this function has a few different solving techniques. You can cross multiply, you can find a common denominator. My favorite technique in a function like this is to reciprocate. My goal is to get y by itself, and I can't do that while y is in the denominator. So something I can do, so long as I do it to both sides of the equal sign, is I can reciprocate the entire fractions. To reciprocate, I get 1 over x equals, when I reciprocate this one, I get y minus 3 over 1. But I don't need the over 1, because over 1 doesn't do anything mathematically. Now that I've pulled the y out of the denominator, I have one more step left to solve, and that's to add 3 to both sides. So I get 1 over x plus 3 equals y, and with notation, the inverse function is 1 over x plus 3. Example 10 is a quadratic function. And again, a word of caution is that quadratic functions aren't technically one-to-one. They don't have inverses. The only way to take the inverse of a quadratic is to only consider half of the equation. So we want to know that x is going to be greater than or equal to 0, since this quadratic starts at 0, 3. Then we can switch x and y. And this equation can be solved in 2 steps. Step 1, to subtract 3. And step 2, to square root both sides. The inverse function is f inverse of x equals the square root of x minus 3. The last example in our notes is a cube root function, and the inverse of a cube root is a cubic. So we are going to solve, fairly complicated with a number of steps, 2 cube root of x plus 1 minus 3. Start by switching x and y. And then we need to remove the outer layers, or the outer operations. So when we're solving an equation, we want to do the order of operations in reverse wherever possible. So the last thing we'll do are the parentheses, the exponents, the multiplication. We'll start with the addition and subtraction. X plus 3 equals 2 cube root of y plus 1. Now we want to divide as we work our way up the order of operations. X plus 3 over 2 equals the cube root of y plus 1. We're finally ready to deal with the exponent. So the opposite of a cube root is a cube power. We're going to cube both sides. It looks like this. And then the last step is to subtract 1. Be careful though, because you're not subtracting 1 from the 3, you're not subtracting 1 from the 2. You're subtracting 1 to this entire expression. So we want to write y equals x plus 3 over 2 cubed minus 1. And then, since I'm out of space on my whiteboard, for my inverse notation, I'm just going to replace the y with an f negative 1x. This concludes part 2 of the video notes for Objective 1E. Be sure to try the book problems and